So let's decide whether this is a reasonable electron pushing arrow. Again, I'll remind you that whenever I pose a problem, my hope is that you've paused the video and tried to think about the problem before you proceed with the video. Well, remember that what we really have to watch out for is forming new pi bonds. And this is forming a new pi bond. You can see the head is pointing to the middle of the bond, so we're forming a new pi bond. And are we forming it with a carbocation? No. Are we forming it with someone that's losing a pi bond? No. So this is wrong. This is an illegal electron pushing arrow, at least if we left it like this. This would not give us a correct answer. So this is wrong. What can we do to fix this? Well, there's no carbocations around. So if we really want to put a pi bond here, the only thing we can do is make sure that that atom is also losing a pi bond. So if we really want to put a pi bond here, we also have to move this pi bond away. And that will make this legal. So let's move this pi bond away. And where can we put it? Well, we have two choices. We can move the pi bond into a lone pair, or we can move the pi bond into another pi bond up here. Either of those might be possible transitions that we might make. And as we go along, we're going to try to learn how to decide which is the more reasonable transition or the more useful transition. Remember that you can't use the as close as possible rule to decide which of these you want to use. You can't say, oh, this is closer than this, so it's better. The as close as possible rule is only when you're comparing two of the same type of transition. So if you're comparing two transitions that are moving a pi bond into a pi bond, then you know you want to choose the one that's forming the closer pi bond. Or if you're comparing two transitions that are moving a pi bond into a lone pair, then you know you want to choose the one that's forming the closer lone pair. But you can't use the as close as possible principle to compare two different transitions. One of these transitions is forming a lone pair and one's forming a pi bond. Well, the as close as possible rule doesn't apply to that type of situation. So we're going to have to learn other tricks to decide which of these is better. Let's think about one at a time. So this would totally be legal. This would be legal. Now notice when we're forming the pi bond, we're doing it with an atom that's also losing a pi bond. Well, that's okay. As long as this atom that's forming the pi bond is also losing a pi bond, we don't need to worry about its exceeding an octet. Do we need to worry about this exceeding an octet? No, because it's not forming a pi bond, it's forming a lone pair. Anytime we form a lone pair, we can relax a little. It's only when we form a pi bond that we can make this really common mistake of exceeding an octet. Okay, so this is a legal set of electron pushing arrows. This would be legal. Now let's make a modification. Would this pair of electron pushing arrows be legal? Give that some thought. Well, we've already decided that this is okay. We're forming a pi bond, but this atom is also losing a pi bond, so that's okay. Now over here, we're forming another pi bond. That's when we have to be careful. We have to be careful about forming pi bonds. Well, are we forming a pi bond with a carbocation? No. Are we forming a pi bond with an atom that's losing a pi bond? No. This atom is not losing any pi bonds, so this is illegal. We're not allowed to do this. This would exceed the octet rule here. Notice that we're trying to learn a method here that shows you when you're exceeding the octet rule without actually having to count all the electrons. Obviously, one way to tell whether you've exceeded the octet rule is to draw in all the hidden hydrogens and then count all the electrons. But that really is much more time-consuming than we'd want to do usually on a problem. Remember, we want to learn a fast and efficient way to do resonance. So here's the fast and efficient way to make sure that you're not breaking the octet rule. If you form a new pi bond, make sure that it's with a carbocation, or make sure that the new pi bond is with an atom that's losing a pi bond. If you follow those rules, you can be sure that you're never going to exceed the octet rule. So that's what we're going to focus on. Well, this atom is forming a new pi bond, but it's not losing a pi bond. So this is an illegal error. What could we do to fix this? Well, we're going to have to move this pi bond away. So I'm going to put that at a tail. Now, where could I put the electrons from that pi bond? Well, one reasonable thing that we could do would be to put them here. So we can put those electrons here. That's definitely legal because it's just forming a lone pair. It's okay to form a lone pair. We don't need to worry about exceeding the octet rule. So this would be fine. But what if we decided to take this pi bond and make it into another pi bond? So one thing we could try to do is this. Could we take this pi bond and put it over here? I hope you gave that some thought. Well, now we're forming a new pi bond, so we have to check this atom. Is this a carbocation? No. Is this an atom that's losing a pi bond? No. So this is not legal. And in fact, there's no way to make this legal because this atom doesn't have any pi bonds to lose. So there's no way to fix this now to make this legal. Another way to see this is we know this is not a candidate for resonance in the first place. Remember a while ago in the videos we learned about how to tell which atoms were candidates for resonance. Well, this carbon was never a candidate for resonance in the first place. So this arrow doesn't make any sense. This won't work. So please notice this arrow does not work and we can't make it work. So let's erase that. Well, again, our problem is that we're trying to move this pi bond to make room for this new pi bond. Well, here's a place that we can move it. Now, does that work? I hope you thought about that. Well, once again, we're forming a new pi bond. Now, this certainly relieves the problem down here. This arrow is forming a new pi bond. But this carbon is also losing a pi bond, so we don't need to worry that this pi bond is going to exceed the octet rule. So now we know that this arrow is fine. This carbon is forming a new pi bond and losing a pi bond, so we're not going to exceed an octet over here. But now we're forming another pi bond, so now we have to check this. Well, are we forming this new pi bond with a carbocation? No, and this is not a carbocation. It's a nitrogen cation, but that's not a carbocation. Is this nitrogen losing a pi bond? Well, it isn't yet. So the way we've drawn it, this is still illegal. The way we've drawn this is still illegal. So by the way, notice that you should make a note that it's only legal to form a new pi bond with a carbocation. Because carbocations always have incomplete octets. Carbocations always have room for more electrons. But you can see that when other nonmetals have positive charges, they still also have a complete octet. You can see that even though this nitrogen has a positive charge, it also has 4 bonds and a complete octet. So you might want to make a note of this. Just because you have a positive charge doesn't mean you have room for more electrons. Just because you have a positive charge does not mean you have room for more electrons. This nitrogen has a positive charge, but you can see that it's got 4 bonds. It doesn't have room for more electrons. It's just carbocations that automatically have room for more electrons. A carbocation always has an incomplete octet, so that's always a good candidate for a new pi bond. But other nonmetals with positive charges do not have incomplete octets. All right, is there any way that we can save this arrow? Well, yes. It's okay to form a new pi bond to the nitrogen as long as we break a bond, as long as we break a pi bond from the nitrogen. Now this is okay because this new pi bond to the nitrogen, this nitrogen is also an atom that's losing a pi bond. So the nitrogen is gaining this pi bond and losing this pi bond. So that would be legal. Do we need to worry about this exceeding an octet? No, because it's forming a lone pair. It's always easier to form a lone pair than a pi bond. So now we have a long string of arrows, and now all of the, putting all these arrows together, this sequence of arrows would all be legal. Here we're forming a pi bond, but we're making room for that by moving this pi bond. Here we're forming a pi bond, and we're making room for that by moving this pi bond. Here we're forming a pi bond, and we're making room for that by moving this pi bond. And here we're just forming a lone pair, and we don't need to make room for lone pairs. We don't need to make room for lone pairs, but we do have to make room for pi bonds, unless we're making them with a carbocation, because that already has room. Okay, so you can see there's many different combinations of legal arrows that you can draw here. We've seen a few of them. And there's also a lot of illegal arrows you could draw. So you got to be careful to only draw legal and not illegal arrows. Now, we've seen that there's many different legal arrows you can draw here. So how do you know which ones you should draw, which ones are useful? Well, we're still not ready to talk about that yet at this point in the videos. So at this point in the videos, we're still not trying to figure out what the most useful arrows to draw are. And we're still not trying to figure out what the most significant resonance structures are. We're still just trying to make sure that we're just drawing legal arrows. And we're focusing on this really important rule that when you form a pi bond, you have to make sure that it's with a carbocation or that it's with an atom that's also losing a pi bond. Is this going to exceed the octet rule? What are we forming? We're forming a lone pair. Lone pairs can never exceed an octet, so no worries. This must be okay. So that's a good arrow. That's a good arrow. Let me erase that and try another arrow. Is that a good arrow? Well, by itself, this is not a good arrow. Why not? Well, we're forming a pi bond. That's when we got to be careful. We got to be careful when we're forming a pi bond. We're not forming it with a carbocation, and we're not making any new room on this carbon. So this must be wrong. This would exceed the octet rule. The only way that this can be right is if we make some new room on this carbon. How can we make, so by itself, this is wrong. How can we make some room here? Well, we got to move this pi bond. We've already seen that this is a legal way to move that pi bond, putting it into a lone pair. So that would be fine.